Oh, what a great day it is today. What the? Why is there a random cave here? Man, is it dark in here? Whoa, what is this place? Where am I? Why is there a golden wall here? Welcome to the dungeon. To pass, you must answer this question. Is that trigonometry? Oh wait, I think I saw something like this before in Miss Atkinson's trig class. Today, we will be going over radians and degrees. Radians and degrees. In order to convert between these two angle measurement units, we'll need to use a conversion factor, or pi radians equals to 180 degrees, or 180 degrees equals pi radians. Now let's take, for example, negative 780 degrees to radians. We'll need to use one of these conversion factors to cancel out the degree symbol unit and leave only radians. So we do negative 780 degrees times pi over 180 degrees. By doing this, we will divide the degree units by each other, leaving only radians left, which is what we are searching for. Now, doing this will give you negative 780 pi over 180, which when simplified equals negative 13 pi over 3. So negative 780 degrees equals negative 13 pi over 3. This must be the correct answer then. Sweet, now I can pass through. Oh my, what is this? Oh look, another gold wall. I gotta get over there. Ah! The second question you must answer. I think I also remember this one from Miss Atkinson's trig class. Hello class, today I will be talking about standard position. The standard position of an angle is when the vertex of the angle sits at the origin of the graph, which is the intersection of the x and y axes. The standard position also contains an initial side, which is a stationary line running right across the x-axis, and a terminal side, which is a line that changes position according to the angle given. Now, let's try drawing the standard position of 210 degrees. This angle is positive, meaning the terminal line will run counterclockwise across the graph. If the value is negative, it would run clockwise across the graph. Now, the first thing you do is draw the stationary line, the initial side. Now, in order to determine the terminal line, we need to understand a few things. The graph is in a plane in a sense of 360 degrees. Passing each quadrant requires 90 degrees. The terminal line has to cross 90 degrees each quadrant. Now, 210 is above 180, so it's already passed quadrants 1 and 2 counterclockwise. Now, since 210 minus 180 equals 30, and 30 is less than half of 90, the terminal side would be a little bit less than half of quadrant 3, because it is less than 45, and this is what the graph will look like. Keep in mind though, this is a rough estimate of the graph, it is not precise. And that's 210 and standard position. Okay, here, I drew out the standard position on a graph of 210 degrees. Is this right? Wow, a new path appeared after solving that trig problem. Another area? Oh my. Time for a swim. Yes, I found the third wallet trig. The third trig problem. Miss Atkinson has taught me this as well. Today's topic is coterminals. Being coterminal in an angular sense means that when two angles have completely different values, but when graphed in standard position, they have the same vertex and sides. Take, for example, 270 and negative 90. They're two different angles, but they are coterminal because they have the same vertex and sides to each other. When asked about coterminal, they will often ask you to find the positive coterminal for a number and the negative coterminal for a number. Take, for example, this angular value of negative 7 pi over 4 radians. In order to find the positive coterminal of this coterminal, we'll need to add 360 to that value. See, since in this equation we're using 2 pi because 2 pi equals 360, but in the concept is you need to add 360 to it in order to find its positive coterminal. For the negative coterminal, we subtract 360, so we subtract 2 pi from this equation. And in the end, the coterminals for negative 7 pi over 4, when added and subtracted 2 pi from, notice how I changed it from 2 pi to 8 pi over 4 for denominator purposes. It equals a positive coterminal of pi over 4 and a negative coterminal of negative 15 pi over 4. And those are the coterminals of negative 7 pi over 4. I think these answers are correct. Let's wait and see. What's this? Answer this bonus question to find the right portal. Another puzzle? Let's see. Convert 19 pi over 7 radians into degrees. Oh, I just solved a problem similar to this one thanks to Miss Atkinson. In order to convert radians to degrees this time, we'll need to use a conversion factor that will cancel out the radian units. So we'll use 180 degrees over pi radians. So 19 pi over 7 times 180 degrees times pi, it gives us a value of 3420 pi over 7 pi, which means that the pi will cancel out from each other, canceling out radians. And so 3420 over 7 gives us a rough estimate whole number value of 488.6 degrees, and that is 19 pi over 7 radians in 2 degrees. This portal has the answer on it, so I guess it is the right one. Wow, is it hot in here? Why are there so many gravestones here? Oh look, it's the fourth wallet trig. The fourth problem to unlock the next area. This one's a bit more tricky, but I think Miss Atkinson has also gone over this before. Our next topic today is sectors. A sector of a circle is an area of a circle enclosed by 2 radii and the arc between those 2 radii. The larger the angle in the sector, the bigger the sector will be. In order to determine the size of the sector, or more in better terms, the area of the sector, we use the equation A area equals 1/2 radius squared times theta. And theta in this sense refers to the angle measured. But remember, theta is always in radians, so be careful of that. So in the equation, the windshield wiper blade, which is 11.7 inches, goes around the circle or upwards to create an angle of about 176 degrees. So the first thing we need to do is we need to convert the 176 degrees to radians using pi over 180 degrees, because that cancels out the degree units. That will give us 44 pi over 45 radians. Now we plug all those values into the equation. 1/2 times 11.7 squared times 44 pi over 45 gives us about 210.2 square inches, and that's the sector, like the sector of the windshield, or like the area that the windshield wiper covers. This gravestone has the correct answer on it, so it has to do something with the golden wall. Yes, I'm so close to breaking free. Let's go! What is this place? Look, a ship! Who are you? I am the final golden wallet trig. To board the ship, you must answer this final question. Tyler and Jordan are partners in a relay race on a curved track with a radius of 19 meters. If Jordan's location on the track is 234 degrees away from Tyler's, how much is the distance between them? Oh my, this one's the most difficult one yet. But Miss Atkison has never let me down. Our final topic for this section will be about arc and arc lengths. An arc is a section of the circumference of the circle, which is basically the outline of the circle. Here, so you see here that the two radii enclose and create a sector, and the arc is a section that's closed in the outline of the circumference of the circle. See here, in order to find the distance or the length of this arc, we use the equation arc length equals radius times theta. And remember, theta is the angle measure, and it's always measured in radians. So in this equation, the radius of the curved track is 19 meters, and the distance between them creates an angle of about 234 degrees. So we see here, our first plan of operation is to always convert 234 degrees into radians. So we use a conversion factor of pi equals 180 degrees in order to cancel out the degree units, and we get 13 pi over 10. We plug this into the equation, 19 times 13 pi over 10, and it gives us the simple value of 77.6 meters. So there's about a distance of 77.6 meters between them, and that is the arc length in the equation. We know that it is arc length in this situation, however, because it tells us, it asks us for distance rather than area. It asks us for a singular distance between 2 points rather than searching for a whole coverage of of the circle. It only asks us a singular distance. So that's how we can differentiate arc length and sector. This is my answer. Will I be able to go through, or shall I not? Farewell. You may now leave in peace. Well, I guess I'm on the ship now. That's the portal I came from. I'm going home. Wow, that was a great review for my trig final today. Okay, class, time for your trig final today. Man, this is a piece of cake, thanks to the golden walls of trig and Miss Atkison. Oh my, this is splendid work. This paper and test deserves an A+. Yay, I got an A+.